Here is our last problem from Monday in class. I know I gave you guys the answer, 2.53, but I wanted to make sure you had a walkthrough of how we got there. So the question is, the activation energy for a particular reaction is 83.1 kilojoules per mole. By what factor will the rate constant increase when the temperature is increased from 50 degrees Celsius to 60 degrees Celsius? For this, we're going to use this expanded Arrhenius equation that we learned about. The natural log of the ratio of K2 over K1 equals negative EA in joules over R, which is that constant, times 1 over T2 minus 1 over T1, and both of those temperatures have to be in Kelvin. So we're going to first make a list of all of the different things that we need to know. We're going to solve for the ln K2 over K1 term first, and the other things we need to know E sub A, that is 83.1 kilojoules per mole, but we need it in joules, so that's going to be 83,100 joules per mole. We also need our R value, that's just 8.314 joules per mole Kelvin. If you ever get confused about what unit your energies need to be in, look at R. It will tell you joules or kilojoules. Our T sub 1 is 50 degrees Celsius or 323.15 Kelvin. T2 is 60 degrees Celsius or 333.15 Kelvin. All we have to do now is plug everything in and crunch our numbers, which we will do. So ln of K2 over K1 equals negative 83,100 over 8.314 times 1 over 333.15 minus 1 over 323.15. Now we start crunching our numbers. I'm going to go kind of stepwise so you guys can see how it goes. Minus 9995 equals, or times, negative 0.000093. ln of K2 over K1 equals 0.929, and that's because we multiplied two negatives together. You get a positive. Now we need to take both sides, put them to the e power. So if we do that, we get K2 over K1 equals e to the 0.929. That's how you undo a natural log. If you calculate that, you find that K2 over K1 equals 2.53. What this is telling you is that K2 is 2.53 times larger than K1, which is answer B. So there you go. This is exactly how you use the expanded Arrhenius equation.